3D printing is revolutionizing the way we create and innovate. Imagine designing a complex object on your computer and then watching it come to life layer by layer. This technology uses materials like plastic, metal, and even living cells to produce everything from prototypes to custom prosthetics. One of the most exciting aspects is its potential for sustainability. By reducing waste and allowing for on-demand production, we can minimize our environmental footprint. Plus, the ability to customize products means we can tailor solutions to individual needs, whether it's a unique piece of jewelry or a specialized tool. As we continue to push the boundaries of 3D printing, the possibilities are endless, transforming industries and empowering creators everywhere. Advances in 3D printing technology have significantly reduced printing times, making it possible to produce complex objects quickly. Technological improvements have enhanced the accuracy and precision of 3D printing, allowing for the creation of intricate designs and complex geometries. Research and development in 3D printing materials have expanded the range of available materials, including metals, ceramics, and biomaterials. Technological advancements have made 3D printing more affordable, with decreased costs for equipment, materials, and maintenance. 3D printing technology enables the creation of customized products with complex geometries and structures. Currently, 3D printing technology has limitations on build size, restricting the production of large-scale objects. Many 3D printed objects require post-processing, such as sanding or painting, to achieve the desired finish. While material options have expanded, there are still limitations on the properties and performance of 3D printing materials. The use of 3D printing technology raises concerns about intellectual property protection and cybersecurity risks. The production and disposal of 3D printing materials and waste can have negative environmental impacts. AI can optimize 3D printing processes, predict material properties, and enhance print quality. IoT connectivity can enable real-time monitoring and control of 3D printing processes. Nanotechnology can improve the properties and performance of 3D printing materials. Bioprinting can create living tissues and organs for medical applications. Swarm robotics can enable the simultaneous printing of multiple objects using a fleet of robots. As technology continues to advance, we can expect to see widespread adoption of 3D printing technology across industries. Enhanced print speeds, accuracy, and material properties will improve performance. Emerging applications in fields like bioprinting, nanotechnology, and swarm robotics will arise. There will be an increased focus on sustainable 3D printing practices and environmentally friendly materials. Integration of 3D printing with other technologies like AI, IoT, and robotics will occur.